All right, so one more word problem for this vector section 9.4. All right, we want to look at how vectors are used to represent, speeds and wind directions and how that would change the course of an airplane. Okay, so a Boeing 737 is flying at a constant airspeed of 500 miles per hour, headed due south. Right? And there's a jet stream blowing 80 miles per hour in a northeasterly direction. So both of these, the airplane and the jet stream, can be represented as a vector. So first, we're going to use V sub A for the vector representation of the airplane, and V sub W for the vector representation of the wind, right, or the jet stream. So the airplane is flying at a speed of 500 miles per hour due south. So if I were to write that or draw that as a vector, due south is down, right? And the magnitude of this vector is going to be 500 because it's the speed, right? So if I were to write this as a vector, the components using I and j, we're not going to the right or left at all. So we have 0, I, and then the j component, we're going down. So minus 500j, right? Here's our vector for the airplane. Now, the vector for the wind, okay, the jet stream is 80 miles per hour in a northeasterly direction, right? So never eat soggy worms. Northeasterly is a 45-degree angle, okay, headed off in that direction. Now, the magnitude of the jet stream is 80, okay, because that's what its speed is. And then the direction, well, northeast gives us an alpha of 45 degrees, right? And I hope you agree. So if we wanted to, we could write the velocity vector here, right? V sub W is the magnitude times cosine of alpha I plus sine of alpha j, right? So we know what cosine of 45 is and what sine of 45 is. So we get 80 times 1 over rad 2 I plus 1 over rad 2 j. So if I wanted to simplify that, I could do 80 over rad 2 I plus 80 over rad 2 j. Okay, so here's the velocity vector for the airplane, and then the velocity vector for the wind. Okay, so how does the wind act on the speed and the direction of the airplane? Right, so first, the way we find that out is we find the velocity of the jet or the airplane relative to the ground. Okay, so pretend this is the ground. So if the plane is trying to, as hard as it can, right, to fly south at 500 degrees and the wind is blowing against it, this vector is acting on this vector. So the velocity with respect to the ground is, how far over is this plane getting pushed? Okay, so we basically want to add those two vectors together. So we want to add 0I minus 500j with 80 rad 2I plus 80 over rad 2j. Excuse me. All right, so if we add our I components together, we get 80 over rad 2I. And if we add our j components together, we get 80 over rad 2 minus 500j. Okay, and we can work out a decimal there if we wanted. Sorry, I got a tickle in my throat here. So 80 divided by the square root of 2 is 56.57. 80 over rad 2 minus 500 is negative 443.43 J. Okay, so here's the vector, okay, with respect to the ground. So what that means is it's going 56 distance to the right and 443 down, right? So we have 56 to the right, 443 down. So here's where the plane is really going. Now the scale is kind of off here, right? The plane's not really veering that far off, but when the wind is blowing in this direction, it is going to blow that plane towards the east, okay? And so we have this x component and this y component, right? So here's the velocity with respect to the ground, right? Now, question C says find the actual speed and the direction of the Boeing 737. So if this is the velocity vector, okay, what's the actual speed? Well, that's the magnitude of this velocity vector, right? And the direction, let's see if we can figure out an angle. And so we can write it in, you know, some sense of direction, using direction words, north, south, east, and west. Okay, so the actual speed of the 737 is going to be the magnitude of the ground vector. All right, so we're going to get the square root of the x component squared plus the y component squared. And I'm just going to use decimals here, okay? I don't need to be too exact. So let's do the square root of 56.57 squared plus 443.43 squared is going to give us a magnitude of 447.02. So I'm just going to do 447 miles per hour. Right, so the speedometer, okay, on the plane says 500 miles per hour, but that wind is pushing it in such a way that its actual distance with respect to the ground is 53 miles per hour slower. Okay, so that's kind of interesting. Now let me draw this vector one more time. Okay, the vector with respect to the ground. Right, so this vector is 56 units over and 443 units down, and so it kind of goes like this. All right, so you can see that the direction of the plane is south and some degrees east. All right, if we did north, south, east, and west here. Okay, never eat soggy worms. The plane is going mostly south with a slight push to the east. Right, so instead of drawing my triangle to the x-axis here, I'm going to draw my triangle here. Okay, so that I could find this slight angle to the east that the plane is being pushed. Right, so I know this is negative 443.43. And I know this is 56.57, and I want to know this angle. Okay, I'm going to call this theta, alpha right here. Okay, and so this alpha right here can be found by using tangent. Right, so tan of alpha, this angle alpha, this little teeny tiny angle right there, opposite over adjacent. So we're going to do 56.57 divided by negative 443.43. Right? So I'm going to get tan of alpha. Let's go ahead and figure out what that is. 56.57 divided by negative 443.43 is negative 0.12 something, something, something. So if I tan inverse that, I get negative 0.727. All right, let me write some numbers down. So then we're going to tan inverse both sides. And I got negative 7.27. All right. So that means this alpha right here, okay, this angle right here is 7.27 degrees. Right? So the direction of the airplane is flying south 7.27 degrees to the east. All right? It's not flying due south anymore. It's got pushed 7 degrees to the east off course. All right, I really like this question. It just had a lot of writing to do, and so that I could do it quickly, I just want to get all the handwriting down first. All right. That completes 9.4.